All right, so in the last video, we learned our basic limit properties, which there's two kind of simple ones. And now we're gonna learn the limit laws, or how do limits interact with other stuff. And then when we put those two things together, that'll be the final video of actually figuring out limits algebraically. All right, so this video is gonna be a little bit dry. We're just literally just gonna go through all the different limit laws, just kind of write them down in your notes, and then the next video will actually use them. So this is basically just gonna be copying stuff down as we go. All right, so to start off, we have these two different functions, f and g. All right, in both cases, we're trying to get close to a, and the limit for f is L, and the limit for g is m. All right, so that's our starting point. We just have these two nice functions with these limits. All right, so our first limit rule, or limit law, is the sum and difference one. So if I'm taking the limit of these two things, all right, so right now there's two separate things, these f and g being either added or subtracted, so I just made it one thing. So you could have a plus here, or you could have a minus here. It allows you to split it up into two separate limits. So now we just take the limit of f plus or minus, depending on which one you started with, and then just the limit of g. And those we know from that starting point is L and M. So really, if you're taking a limit, you can break it up over pluses and minuses, and then just add the answers from that together. All right, next one is actually a really important one for a lot of calculus stuff that we'll do. If I have some constant number that I'm multiplying by my function, what I can do is just bring that out in front of the limit. All right, so that c just jumps out here. So this example, if I had, say, 4x, 4 is just multiplying by the x, so I could bring the 4 away from the x. So that's a constant multiple. It's just some number that's being multiplied by the rest of the expression. And then again, this part we know the answer to from up here. So that's how we get our answer for the limit. All right, so constant multiple is just something that's being multiplied. We can bring it out. All right, product, exact same as the sum or difference. The only difference is now I have multiplication. So I split it up into two separate limits over the multiplication. We just did multiplication, we have to do quotient. So again, if you are dividing inside the limit, what I can kind of do is break this limit up onto the top and bottom. All right, so just like we did with addition and subtraction and multiplication, you kind of break it up over that operation. The only thing we have to make sure is, since there's division, we got to make sure we're not dividing by 0. All right, but same thing, we can break up our limit over that division and just make sure it's not 0. We'll deal with what happens when it's 0 later. All right, exponents. If I have some whole function raised to an exponent, what I can do is bring the limit inside of that exponent, basically. And then now you can see the exponents after the limit rather than before the limit. All right, so that just allows me to kind of simplify the limit by doing exponents last rather than before the limit. And the last one, all right, so this last one you just have to kind of blindly copy down, is square roots. Well, not square roots, it could be cube roots, any nth root. All right, so if I have a root, again, the limit can kind of jump inside the root, and then now the root is on the outside, so I do the limit first, and then the nth root. And again, we know how to do the limit because that was part of the definition up there. All right, and again, we also have to make sure that that satisfies all the conditions for an nth root. For instance, you can't take the square root or a fourth root of a negative, that type of thing. Odd roots, it doesn't matter. All right, so those are our 6 limit laws. Again, right now just copying down, but you can see what we can do is break up one, say up here with the quotient rule, we can take one complicated expression that we're going to do the limit of, instead break it up into multiple limits with simpler expressions. So this is what we're going to end up doing. We had those rules with c and x in the last video. We're going to slowly break up until we only have c and x, and then kind of put it all together at the end. All right, but for right now, just have these limit laws written down, and then we'll use them in the next video.